Ever feel like you're standing completely still? Well, guess what? It's pretty much an illusion. In this explainer, we're going to pull back the curtain on the invisible patterns of motion that are happening all around us, all the time. It's wild.
So, let me kick things off with this question for you. What if everything, and I mean everything, is moving, even when something looks perfectly still? It sounds simple, right? But the answer? Well, it opens up a whole world of incredible physics.
I mean, you see motion everywhere. It's obvious. A car zipping down the street, a fan spinning overhead. That's the easy stuff. But what's really mind-blowing is that the air you're breathing right now is like this chaotic storm of constant, invisible movement.
Okay, so what do scientists actually mean when they say motion? It's actually super simple. It's just the change in an object's position over time. But, and this is key, compared to some other reference point. This one little rule, it's the key to unlocking everything we're about to dive into.
All right, so to get started, let's look at the most basic thing about motion, the actual path an object takes to get from point A to point B.
You know, the most fundamental path you can imagine is just a straight line. In physics, we call this rectilinear motion. It sounds fancy, but it just describes anything traveling from one spot to another without turning or curving. And you see this everywhere. Just think about it. A train barreling down a straight track, a car cruising on a long, straight highway, or even something as simple as a stone falling straight down from your hand. All perfect examples of rectilinear motion.
Okay, but what about things that are clearly moving, but they're not really going anywhere? That's where rotatory motion comes in. This is when something spins around its own center, its own axis, pretty much staying in the same spot. I mean, the Earth spinning on its axis is what gives us day and night. A ceiling fan cools down a room by spinning in place. And a spinning top? It's just mesmerizing, right? All of that is rotation.
Now, let's look at something that sounds similar but is actually really different. Circular motion. Now, this isn't about an object spinning on itself. No, this is about an object traveling along a circular path, going around some other point outside of itself.
Some great examples are the hands of a clock, right? They move around the center of the clock's face. Or think about the moon making its orbit around the Earth. In both these cases, the object itself is following that circular track.
So, to put it really simply, rotatory motion is an object spinning on its own axis, like a top just spinning in place. Circular motion is an object traveling in a circle around something else, like the moon going around the Earth. It's a subtle difference, but it's a really important one.
Okay, so motion isn't just about the paths things take, it's also about rhythm. Now let's get into the really cool patterns you see in movements that repeat themselves.
Have you ever just watched a swing at a playground? That perfect back and forth movement around that middle point? That's called oscillatory motion. It's basically any kind of repetitive to and fro action.
And we see this all over the place. A kid on a swing, the pendulum in an old grandfather clock. You can even do it yourself. Just hold a ruler on the edge of a desk and give it a flick. That vibration? That's oscillation. It's a super common pattern in the natural world.
Now, things get even cooler. Within that big category of oscillatory motion, there's a special, almost perfect version called simple harmonic motion, or SHM for short. What makes it special is that there's always a force pulling the object back towards the center, and that's what defines the whole movement.
Think about the gentle, predictable swing of a pendulum, or the vibration of a spring after you stretch it, or even the hum of a tuning fork. These are all beautiful examples of this pure rhythmic motion, where the object is constantly trying to get back to its resting spot.
So here's the key takeaway, right? Any back and forth movement is oscillatory. But when that movement is specifically driven by a constant pull back to the center, that's when it becomes simple harmonic motion. It's the specific versus the general.
So far, we've been talking about motion you can see with your own two eyes. But what about all the movement that's happening at a scale that's just too tiny for us to see? Let's zoom way in.
Get this, even a glass of water that looks completely still is actually a wild, chaotic dance of countless tiny molecules. This constant, random jiggling of particles in liquids and gases, that's what we call kinetic motion.
And this invisible chaos, it has effects we can definitely see, or smell. Because the particles in a gas move so randomly and have so much freedom, the scent of perfume can travel all the way from one side of a room to the other. That's kinetic motion in action, right there.
And there's a really direct connection here. Temperature is basically just a measure of how fast these molecules are moving.
So when you heat something up, what you're really doing is giving its particles more energy, which makes them zoom around even faster. Simple as that.
So, from the path of a massive planet to the tiny jiggle of a single molecule, we've seen that the universe is just always on the move. Let's do a quick recap of these fundamental patterns we've talked about.
Okay, let's bring it all home. We started with the simple paths, right? Rectilinear for straight lines, rotatory for spinning in place, and circular for when something is orbiting something else. Then we explored those repeating rhythms, from the general back and forth of oscillatory motion to that super-specific centered pull of simple harmonic motion. These are like the basic building blocks for all movement.
So by understanding these patterns, we can start to see the hidden rules that are secretly running our world. And it really makes you wonder, doesn't it? What other invisible forces and patterns are out there, shaping everything around us, just waiting for us to notice them?